All right, it's already 11. Hello, everyone. Thank you very much for joining. Before I start an actual presentation, I need to go through the couple of slides from the event organizers. So this is the code of conduct. You are also welcome to donate. And thank you very much for the sponsors for helping this event to happen. And also please make it social, spread the word about it. Hi again. My name is Eugenia, and today I'm going to talk about a finite state machine on the front end. This is the first time I'm joining developer event. The first time I'm joining UK event, and I'm joining you from Berlin, Germany. I'm working as a software engineer at Raisin. Raisin is a banking platform where you can invest and save money. By the way, it is also operating in the UK. And I'm former Google Developer Group organizer and Women Tech Makers lead in Latvia, because previously I was living in Latvia, but then I moved to Germany. And here is my Twitter tag, and also I'm writing some articles on Medium. And this is how I spent try to survive in the boredom of lockdown, drawing watercolor paintings and listening to jazz divas. I assume that the audience is very diverse. That's why I will try to make it very simple and to explain every detail. So first of all, what is a finite state machine? This is a pretty old, actually 60 years old mathematical concept, which is widely used in electrical engineering, in hardware, on the backend services as well. There are some software design patterns that are based on it. However, it also can be applied to the front end, and I'm going to show you how. A finite state machine is, so this is the illustration of it. This is an abstract machine which can be only in a one state at a time. For example, state S1. And a machine can transition to another state in response to external inputs. For example, input A. So when a machine receives this input, it transitions from state S1 to state S2. This machine has a limited amount of states. It also has an initial state and a final state. But the most important thing that will follow also in the presentation later on is that there is no chance that this machine can be in multiple states at once. One of the most simple examples from real life could be a traffic light. There are 3 states in total. It's red, green, and yellow, and the transition between states is happening with help of timers. So, and if a traffic light is implemented as a state machine, then there is no chance that red and green can be switched on at the same time. I have prepared a small part of the application which is responsible for file upload. And further on, I will refer to this small application. So let's see what it does. There is a button, add attachment, meaning upload the file. And user selects a file. When the upload is happening, we show loading indicator, and if it was successful upload, we show that success happened. But if in some cases there will be a file which will fail, we still show loading indicator, and when failure happens, we show an error message and also provide possibility for a user to retry. And at any step of this flow, user can cancel uploaded file. If we try to visualize this flow, it will look like draw a flow chart, specifying user actions and system operations that are needed to be done in response to this user actions. So it will look something like this. When user uploads a file, the application is showing loading indicator and sends HTTP request. At this point, user can cancel the file upload. And then everything will start from the beginning. But in case it didn't happen, then the application is waiting for the HTTP response. And if it was successful, then we need to show a success message from where user can cancel the uploaded file. Or if request failed, then we show an error message from where user still can cancel, or he or she can retry and go to this step again. And all this logic needs to be implemented on the front end. So I'm usually at work, I'm using React.js library, and I will be using it in the examples on the next slides. But my main idea is not about technology you're using, it's not about the library, but about the concept of how you can apply a finite state machine to your application, regardless of technology you're using. So, but first, this is like a typical implementation, how we front-end developers would approach the implementation of the flow I just showed you. First of all, we would define multiple states. Like we need a state to store a file to be able to do initial file upload, and also we need to keep this file in order to be able to retry file upload if user chooses so. Is loading to show loading indicator, is success to identify that success happened and show success state, and also error to store the error message and identify that failure happened. And here is a part of code of the file upload component, which is rendering smaller UI elements, like, for example, file input, which you see is looking like this attachment button, and also different attachment blocks, for example, loading, failure, and successful completed attachment block. And the rendering of these UI elements is based on these multiple state values we have defined at the beginning. So it's loading, error, is success. And theoretically, if the developer makes a mistake, nothing is preventing is loading and is success be true at the same time. Also, as you see, we need to handle different scenarios like cancellation, retry, and also the initial file input. And all these handling functions will be also located in the UI component. So we need to handle all this different logic. And for example, when we handle a cancellation, there will be multiple handling functions for the cancellation, because depending on the current state of what is happening with the file, is it loading or did it fail, we need to change state in a different way, because these values differ based on the current situation. And although it's a very simple example and we haven't written a lot of code yet, this is a bad approach because we're creating quite convoluted logic that is hard to understand and therefore easy to break. And if you will try to implement a new feature within this flow, it will be difficult and will become even more convoluted. So there is a big likelihood that such a code will contain bugs. But we can look at the problem from a different point of view, which is a finite state machine. And, the first time I crossed over this finite state machine topic was a few years ago when I worked in N26. N26 is a mobile bank very popular in Europe. It was in the UK for a while as well, but not anymore. But I was working in a team which was responsible for creating customer support chat. And we didn't came up with finite state machine solution at the very beginning. Although the flow we needed to implement was quite like complex because it contained a lot of different steps. For example, user needed to be verified. There was 2FA verification before you can join the chat, and also you can chat with a chatbot or a customer support agent. Then if you wait for a customer support agent, you need to we need to show this like a waiting, that customer is waiting in a queue. So it was also a different view. The chat UI also is very dynamic, like it needs to be interactive. So that was a lot of logic inside this application, and although it took us lots of time to refactor to use an actual finite state machine concept in this application, it was definitely worth it because it brought a lot of, it simplified a lot of things. So, but if we come back to the file upload flow I showed you at the beginning, what I have done with this flow is I divided it into slices or views. And for each view, I will define two things. The first one is state, and the second one is events, which can happen from this state. So the very first view is this one. This is like initial view, and I call it like idle. And possible events that can happen from this view is input, meaning user inputs a file. And if this event happens, then we go to the next view, which is loading. So I call this state loading, and possible events that can happen from this state, user can cancel, or based on the results of the upload request, it can fail or it can succeed. And if it was successful, then this is the next view that we're showing to the user, and we call this state complete. And possible events that can happen from this state is just cancel. But if the request failed, then this is the view we're showing. We call it failure, and possible events that can happen from this view are cancel and retry. And based on this, we can draw a finite state machine, defining all possible states, idle, loading, failure, and complete, and also defining transitions between these states. For each transition, we are giving it the name of the event. Input, retry, fail, succeed, cancel. So there are a few points that I would like to stress. So in this finite state machine, it is very important that there is no way we can transit from idle to complete without reaching loading state. And there is also no way, for example, when user is on this failure view, they click cancel and they end up in the loading state. The finite state machine just does not allow such a thing to happen. So although it is a finite state machine, it's a very good start. This is not enough to implement the whole flow. because we have also a file upload request that we need to handle somewhere, and this is happening on the loading state. So we need to enrich our Finite state machine with on enter event. And we need to say that when we enter loading state, we need to trigger an upload request. Also, there is some data like error message and also file that we need to keep during the whole user flow in order to be able to display it to the user, or file we need it to be able to retrieve it. And we can enhance our Finite state machine with the context, where we will store all these values that we need. However, as you see, this is not a Finite state machine anymore. It's much more complex. And in the front-end world, there is something called state chart, which is a beefed up Finite state machine. And it is beefed up with different features like enter-exit events, automatic transitions, substates, actions. Actions are side effects that you want to trigger when you enter a particular state, or guards. Guards are conditions that you can specify for a transition to happen. For example, if the condition is not true, then you cannot, your machine cannot transition to a particular state. But we're not going to use automatic transition, substates, guards. The only thing I will be using in the example is enter event and also actions. So in the example, I'm using a JavaScript library called xstate. This is a very, very nice library that provides you with a lot of different features about how to implement Finite state machines. And one of these features is also visualization of your state machine, which I'm going also to show you later. So when we start to do actual coding, the first thing we're doing is we define the state machine, which is basically just an object where we define fields like states. In this field, we are listing all the states the machine could have. It's idle, loading, failure, and complete. And for each state, we define transitions, all possible transitions that this state can have. And a transition here is a key value pair, where key is the name of the event and value is the name of the next state to which a transition should happen. So yeah, you define it like this. And then there is a part of states. We also need to handle file upload. And this is happening when we are entering a loading state. So in our file upload machine definition, we are defining invocation of a function which is responsible for file upload. So here is this function. I haven't pasted the whole code here to save a space, but here what we are doing, we're preparing file for upload and doing an actual HTTP request to upload the file. And this function can end up into two results. It's a successful one and or failing. And we're handling these two scenarios with this like callback things. So if it's a success, then it's this one, and on failure we handle it in this way. So and if the upload was successful, the next state to which machine should transition is complete, and the actions, like a side effect that we need to perform when this happens, is we need to save a file name to the context of a state machine, because file name was something we were showing as an indicator that file was uploaded successfully. And in case of failure, the target state to which machine should transition is failure, and we are saving to the context another data, which is error and file. And as we are already using a context, we need to define initial value in the state machine definition. So this is initial value of the context. All values are empty, and we also need to define initial state, which is idle. So, and based on this definition, we can already visualize this file upload state machine. So what I have done, I just copied a machine definition here. And here you see all the states we have defined. The only difference is that when we invoke an upload function, I'm mocking it here in order to simulate different scenarios. So I would like to show you the successful one and a failing one. So the first one will be successful. We can straight away go to and see how to see the flow. So the first state is idle, and when user inputs a file, we go to the loading state. And from this state, file upload was successful, so it was done, and machine transitions to complete state, from where user can just cancel. But in case of failure, so we start in the same way. User inputs a file, we show loading, but we got a failing response, and machine transitions to failure state, from where user can retry. In this case, we show loading again, and it will go, of course, to failure, from where user also can cancel. So in this way, you can test the user flow. You can check, like, have you planned all possible scenarios that your feature needs to have, and also is there a risk you can end up in unexpected state. So it's very, very nice to test your flow before an actual implementation. So what we have done, we moved the almost entire logic to the finite state machine definition. And in order to see the benefits of how it will look in the UI component at the end, I have prepared the comparison before and after. So before, in our UI component, we're relying on multiple states in order to render necessary UI elements. And there was a chance, due to some mistake, that those values could be true at the same time. However, when we use a finite state machine, we rely in this case only on one value, which is the current state, and there is no way it could have multiple values. And also, before, our UI component was holding different handling functions for different scenarios like cancellation and retry. However, currently, in these scenarios, the only thing that UI component is doing is sending a necessary event to the finite state machine. For example, in case user clicks cancel, we're sending cancel event to the finite state machine. And in this case, a finite state machine is in failure state. And when it receives this cancel event, it will know that it needs to transition to the idle state. The same thing will happen with retry. And also, as you see, we are not storing the states in UI component anymore. When we need to display an error to the user, we take it from the context of a finite state machine. When I first time saw this concept, I liked it a lot, and I'm sure that it's very good for event-driven and complex UIs. When your UI is dynamic and the user interacts with it a lot. It also brings clean and readable code, and it's scalable, because if you will introduce a new step in your flow, you will just add a new state. It is also easy to test, and it is easy to visualize. It doesn't matter, are you using this JavaScript library or are you just drawing the finite state machine yourself? Both ways works, and this visualization is helping a lot. However, I also agree that it might be quite complex and time-consuming to implement. First of all, because you need to get this concept, and there is some learning curve. But also, you cannot jump to the implementation, to writing the code straight away. You need to take time to plan your finite state machine, which is very good because you avoid mistakes before you made them. And I think there is a risk of over-engineering it, because some simple flows, like, for example, just a button click, and when you click a button, it changes the color. Such things don't require any finite state machine, to my mind, because you will just make it more complex than it is. And I have prepared the Triple D, like the name of the conference, but so if you would like to if you would like to rethink your user flow as it would be a finite state machine, then the first thing you need to do is divide your UI flow into multiple views. And for each view, you define a state and also possible events that could happen from this state. And then this is enough for you to draw a finite state machine. And then after you do it, you can also enrich it with different side effects that you need to perform and so on. So thank you very much for listening. You can find also the entire application code here, following this link. And I'm very happy to answer your questions. You can post them in the Q&A section. Ben, are there any questions?
We've not had any questions through yet. We'll give it a little while to see if people want to put some questions in the Q&A section, and then if not, we'll wrap up there. Okay. Yeah, there don't seem to be any questions coming through. So,
but feel free to write me on Twitter if you come up with, like, if some questions will appear. And thanks a lot.